we have the integral of 3x e to the power x dx. So for this question, we are going to use integration by parts. So if we recall the formula, we know that the integral of u dv should be equal to uv minus the integral of v du. So in order for you to choose your u and v, you have to make sure u is the one which is easily differentiable, and it also helps the power of x reduce. So in this case, we take 3x as u, because if you differentiate that, the power of x will reduce and we'll just have a 3 left. So u being equal to 3x and dv being equal to e to the power x, this would give us du by dx, which is 3, and the integral of e to the power x, which is just e to the power x plus the c, right? Substitute into our formula, we should get 3x brackets e to the power x plus c minus the integral of 3 times e to the power x plus c. If we disregard the constant, which is 3, it means we just need to integrate e to the power x, and that will give us e to the power x again. Now, multiply by the 3, we'll have 3 e to the power x plus a c, because if you multiply 3 by a constant, it will still give us another constant. Now, if we regroup the values that we have got, we would have the integral of u dv being equal to 3x times e to the power x plus c minus 3e to the power x plus c. And simplifying that, we should have 3x minus 3 e to the power x plus c. Question number 15. So we have the integral of x cos 4x dx. So we are going to take u to be x, since it's easily differentiable. So if u is x, that means dv would be cos 4x. Now du by dx is just 1, and then v will be the integral of cos 4x, which is 1/4 sine 4x, which we had seen in a previous question. So now we substitute the values of v and du into the formula for integration by parts, and we should get this. So now we're going to focus on the right hand side of the equation to integrate 1/4 sine of 4x. So we take out the constant, and if we integrate sine of 4x once again, we should get negative 1/4 cos 4x. Okay, simplifying that, we would have 1/16 cos 4x, and then our final answer would be 1/4 sine 4x plus 1/16 cos of 4x. Question 29. We have the integral of x e to the power 2x plus 1 dx. So if we let u be equal to 2x plus 1, this would imply du by dx is equal to 2. Now that would simplify the function for us, but then we'll still have x in the beginning. So I think we might need to use integration by parts. Okay, so if I replace the value of u, I'm going to have integral of x e to the power u du over 2, just like I said. And if now s is equal to x and dt is equal to e to the power u, which is integration by part, ds over dx equals to 1, and then t will equal to integral of u e to the u, which is still e to the u, right? Now substituting the formula for integration by parts, this would be st minus integral of t times ds over dx. Substituting each of those values, we'll have half times x e to the power u minus integral of e to the power u, which is still e to the power u. We are going to replace our value of u, and we get our final answer, which is half x e to the power 2x plus 1 minus e to the power 2x plus 1. Of e to the power x sine x. Now this question is very interesting as we are going to get a loop. We're going to get stuck in a loop, but then I'll show you how to work through that. So let's begin by taking u as sine x and dv as e to the power x. In this case, you can take either of them as u or dv because either of them are easy to integrate or even differentiate, right? So in that case, the derivative of u would be cos x, and the integral of v would just be e to the power x. Substituting this into the formula for integration by parts, we're going to have sine x e to the power x minus integral of e to the power x cos x. And then we repeat the process again. T, but this time around with different variables, of course. Okay, so we're going to let t be equal to cos x and dv equal to e to the power x. Differentiating and integrating respectively, we're going to have dt being negative sine x and v being e to the power x. Okay, let's go ahead and substitute these right into the equation. We would have sine x e to the power x minus cos x e to the power x minus e to the power x sine x, right? That will turn into positive. Okay, expand the brackets. We would see that there are 3 negative signs in front of the integral. So there's 2 just right beside it, which has been sandwiched with the integral, and then 1 extra just before the big square bracket, giving 3 minuses, which would make a final minus, right? So we have e to the power x sine x minus e to the power x cos x minus e to the power x sine x. Okay. Here we are going to have to bring e to the power x sine x over to the left-hand side. This is what I mean by we're stuck with the loop, because if you keep on replacing u and dv, it's going to keep going on and on. So we need to bring it to the left-hand side and add them up. So both integrals will give us 2 of the integral of e to the power x sine x. And we're going to divide both sides by the 2. This is going to give us e to the power sine x minus e to the power cos x plus c, all divided by 2. Question 97. Find the volume of the solid revolution obtained by rotating this region about the x-axis. Y equal to x sine 3x for pi less than x less than pi over 3. Okay, for volume of integration, remember we need to do the integral of pi y squared. So we must square this y before plugging in the formula. That will be 0 to the pi over 3 of pi x sine 3x all squared. Good. So if we expand the brackets, this is going to give us the integral of pi x squared sine squared 3x. Now, sine squared x is equal to half minus 1. Half into 1 minus cos 2x. So what would be 3? We use the same tactic that we did before by multiplying this equation by 3, which would be half into 1 minus cos 6x. Now we have the integral from 0 to pi over 3 of pi x squared times half times 1 minus cos 6x. If we take out the constant, we have 1 over 2 pi, then x squared times 1 minus cos 6x. If we expand the brackets, we're going to have the integral of x squared minus x squared cos 6x, right? Now, the problem will be to work out the integral of x squared cos of 6x. We would need to let u be x squared and dv be cos 6x, which is integration by part. Differentiate, but I think this time around we need to differentiate twice to get rid of the x completely. So differentiate that, we will have 2x equals, we'll have the du by dx equal to 2x and v equal to 1/6 sine of 6x. Now our volume is half pi from 0 to pi over 3. So if this is our equation that we're trying to integrate, we replace each of the values. We'll have x cubed over 3 minus x squared sine 6x over 6 plus integral of 2x over 6 sine 6x. Once again, we can still take u to be equal to x, dv equal to sine of 6x. If u is x, then du will be 1, and if dv is sine 6x, therefore v would be negative 1/6 cos of 6x. Okay, substituting these into the right hand side of the equation, we're going to have our new integral. 2/6 of x sine x is actually 2/6 of x negative x over 6 minus cos 6x over 6. So we're going to replace this value that we got into our equation right over here, such that we have the volume being equal to half pi x cubed over 3 minus x squared sine 6x over 6 plus 2/6 x sine 6x dx. Now our final answer would be 1 over 2 pi x cubed and so on plus c.